And so now the next two shapes that we're going to talk about are pyramids and cones. Difference between pyramids and cones is that they only have one base. So you had your pyramid and your prism, that these can be exactly the same, right? These have the same base. They both have this hexagon base. This is a hexagonal pyramid versus this is a hexagonal prism. Difference being the one base versus the two bases. And then same thing will happen with my cone to cylinder. Cylinder has my two bases, cone has my one base. And what a pyramid and cone both do is they both meet at the top at this vertex, the point where it meets. Now that vertex is actually directly opposite the center of our base. And so that vertex is directly opposite the center of our base. In both situations, that's our vertex. And then what you have with pyramids and cones, let's go ahead and take a look at what they're made out of. So a pyramid, if you were to unfold it, is actually made up of, in this case, because my base is a hexagon, it's going to be made up of 6 isosceles triangles that all meet at that same point. So the triangle would have a height that goes through the middle of the triangle and a base that's right along that base edge. And then a cone is an interesting shape. A cone, when it unfolds, actually unfolds and looks like a part of a circle, which if you recall, that's actually a sector. But also if you look at it more specifically, we can think of it as being made up of infinitely many triangles. And so we can find the area of a triangle as one big triangle where the base is kind of wrapping around that circle. And the height is this slant height along the edge of your cone. So the height of our triangles is this slant height. So there's actually some vocab to talk about. And I'm going to talk about it in a pyramid because I have this fun pyramid here that I have for demonstrating this. And basically in a 3D solid, so this is a triangular pyramid because it has that triangle base on the bottom, the yellow base. And then we look at it and there are 2 different heights that we need to talk about. And there's also this lateral edge. The lateral edge is where the 2 triangles meet. So that's our lateral edge. But then we have this height. So I have to make sure the reflection of my window isn't getting in here. This red line that I have going inside the shape, if you notice it, it's actually meeting at the base, the center of my base, and it goes up to my vertex. That is how tall the pyramid is. So if I wanted to measure how tall it was, we would want to go from tallest point to lowest point. And so that red line right now represents our height. It is inside my shape, not on the outside, not slanted, not diagonal. It is inside my shape. And so then our next part that we have is I can actually take this and move it out to the outside here. And I want you to look at where that line is. That line is on the edge. So this is actually called our slant height. Why? Because it is literally slanted. It's hard to show not getting the reflection of my window, but it's slanted along the edge of my pyramid. So I'm going to actually take my other pyramid back and talk about this for a minute. What it is that I have my slant height along the outside, and then I would have my vertical height along the inside. So there's a difference between those 2 heights in a pyramid.